Hello everyone, this is a video solution for question 4 in tutorial 4 regarding the ideal gas equations. So the question asking us to calculate the mass of the gas depending on all these variables being given. Okay, so again we're going to use the ideal gas equation in the formula sheet. So first of all, I'm going to write PV is equal to mRT. Okay, so in this case we're going to calculate the mass of the gas here, mass, and then I'm going to divide RT on both sides so that I have PV over RT. Okay, then we just find out all the information given in the question. At the same time, we're going to convert everything to SI base unit. So first of all, pressure 12 bar. Okay, so 12 bar converted to Pascal. Volume, so that's already in cubic meter, so we don't have to do anything on that. Over R and R times T. So R here for this gas, R has already been given here. Okay, but again, be very careful. This is in kilojoule, which is not SI base unit, so we need to convert that to joule. Okay, by times 1000 times the temperature. So the temperature is 140, so that's degree. So we need to convert to temperature by add 273 plus 140. Okay, and then we can get the result, which is in SI base unit as well, which is 0.177 kilogram. So this is basically the first question. The second question, the final temperature of the gas. So if you have a look at the question, it says if the gas is expanded, so that's a process, and then we know the final pressure, which is P2. Okay, so we can assign a subscript 2 for the end state, and for the initial state we use 1, and the volume, that's V2. Okay, P2 and V2 respectively. So what we can use is that, again, we can use in the formula sheet, we can use PV over T, which is a constant during any process for an ideal gas. So this gives us P1 V1 over T1 is equal to P2 V2 divided by T2. And in this case, we're going to calculate the final temperature of the gas, which is T2. And then we're going to rearrange this. T2 is equal to, so I would do, normally I would do the multiplication like a cross. Okay, so you have P2 V2 times T1 over P1 and V1. So I arrange everything here. You can see P2 over P1. So this is a ratio. It's like a dimensionless value. V2 over V1 is also a dimensionless value. Okay, so if I write a P2 temperature 2 bar over P1 is here 12 bar. V2, so V2 is here 0.058 over V1, V1 is here, times T1. So T1, again, we need to convert that to Kelvin temperature. So that's 273 plus 140. And then we can calculate the temperature is 222.2. Kelvin. Okay, so that's a video solution for question 4.